It arrived on a Tuesday, a faint, almost imperceptible stream of data trickling into the deep space network. For over 47 years, Voyager 1 had been our steadfast messenger from the cosmic ocean, its voice fading with distance. But this transmission was different, a fragmented sequence, a whisper that defied its own programming. It was a puzzle broadcast across 15 billion miles, a final enigmatic greeting before silence. The signal was weak, barely above the universe's background hiss, yet the pattern was unmistakable. A short, structured burst of binary code, unlike any known telemetry or scientific reading, repeated itself. For the team at NASA's Jet Propulsion Laboratory, disbelief gave way to profound curiosity. These scientists knew every quirk of Voyager, but this was an anomaly, a ghost in the machine. Initial caution gave way to intrigue as the data was cleaned and analyzed. The explanation of random malfunction began to crumble. The signal's structure was too elegant, too organized for chaos. Had Voyager in its final moments sent us something truly new? The question hung in the air, heavy with possibility. The universe, it seemed, wasn't done surprising us, and our oldest explorer had just delivered its most profound mystery. To grasp the significance of this whisper, you must understand the Voyager program. Launched in 1977, Voyager 1 and its twin, Voyager 2, took advantage of a rare planetary alignment for a grand tour of the outer solar system. Using gravity assists, they became cosmic pinballs, rewriting our textbooks. Voyager 1 gave us our first close-ups of Jupiter's storms and Io's volcanoes, then revealed Saturn's rings and hidden moons. These distant worlds became dynamic, active places in our eyes. After their planetary encounters, the Voyagers kept going, toward the edge of the Sun's influence. In 2012, Voyager 1 crossed the heliopause, entering interstellar space, the first human-made object to do so. It became an interstellar scout, sampling the Milky Way's particles and magnetic fields. Voyager transformed our view of the solar system, pushing technological boundaries with a computer less powerful than a car key fob. More than that, it captured our imagination, especially with the pale blue dot image, showing Earth as a tiny speck in a sunbeam. It gave us a profound sense of our place in the cosmos, small, fragile, and precious. Bolted to each Voyager is a golden phonograph record, a message in a bottle for the cosmos. Conceived by Carl Sagan's team, the golden record is a time capsule. 115 images, sounds of Earth, and music from Bach to Chuck Berry. Greetings in 55 languages from ancient Akkadian to modern Chinese offer peace and friendship. The cover includes diagrams showing our solar system's location and instructions to play the record. The odds of an alien civilization finding it are infinitesimal. The Voyagers are tiny specks drifting for billions of years. But the act of creating the golden record was a message to ourselves, a reflection on what it means to be human. The spacecraft became more than robotic explorers, they became cultural artifacts carrying our story into the void. So when one sends back a final puzzling message, it feels different. It's not just a malfunction, it's as if the messenger itself has developed a story of its own. The symbolism is almost too perfect, a cosmic echo of the very purpose for which it was built. The golden record's existence adds poetry to Voyager's mission. It's a testament to our hope and curiosity, and now the messenger's last word is a riddle for us to solve. Voyager 1's final transmission, received August 7, 2025, was unlike anything before. Normally Voyager's data is structured, telemetry and science packets in binary. This time it was a short, repeating burst lasting 92 seconds, just 1024 bits or 128 bytes. The fragment structure was puzzling, not random noise but a clear repeating pattern. When plotted visually, the binary formed a symmetrical geometric shape. The sequence contained an unusual number of prime numbers, statistically significant and too orderly for chaos. The signal lacked standard headers, as if Voyager skipped formalities and sent only the core message. Engineers checked for known bugs or failure modes, nothing matched. The FDS had sent garbled telemetry before, but this was different, not garbled, just new. The signal traveled over 23 hours from 167 AU away, its power billions of times weaker than a watch battery. Extracting such a structured signal from cosmic static was a monumental feat. The content was compelling, a perfectly formed piece of data with no known origin or purpose. The mystery deepened. What was Voyager trying to say? Once the anomalous signal was confirmed, NASA's Deep Space Network sprang into action. The DSN's global antennas, California, Spain, Australia, focused on Voyager's last known position. No longer just listening, They sent commands in the blind, hoping for a response. Each command took 23 hours to reach Voyager, and another 23 for a reply, a painstaking process. Meanwhile, JPL teams began forensic analysis, cross-referencing the signal with data from other observatories. Was it solar activity, a cosmic event? Every environmental factor was considered and ruled out. The scientific method was in full force: gather data, form hypotheses, test against evidence. Fault trees mapped every conceivable cause, from failing capacitors to unknown interstellar phenomena. The goal: systematically eliminate possibilities until only the most likely explanation remained. The world's best minds were on the case, determined to solve Voyager's final riddle. The stakes, nothing less than understanding the last message from humanity's farthest explorer. The heart of the investigation was decoding those 1,024 bits. Cryptographers, computer scientists, and astrophysicists scoured the sequence for known patterns. No match. The data was unique, written in a language Voyager wasn't supposed to know. Mathematical analysis revealed high Kolmogorov complexity, information-rich, irreducible, and structured. A simple hardware fault would produce a simple pattern. This was the opposite. Radio astronomers found a subtle Doppler shift in the carrier wave, suggesting a tiny, unexpected change in Voyager's velocity. What could cause a 2,000-pound spacecraft to change speed in interstellar space? The investigation became global. NASA shared data with ESA and universities worldwide. New eyes brought new ideas. Was it a mathematical sequence, a compressed image, or a new error-correcting code? The team worked around the clock, fueled by curiosity and the desire to understand Voyager's last word. Every clue added a layer to the mystery. The world watched as the puzzle deepened. The answer, everyone hoped, was within reach. The investigation began with the usual suspect's technical failure. Voyager's hardware, nearly 50 years old, had survived decades of cosmic ray bombardment. A single high-energy particle can flip a memory bit, causing unpredictable software behavior, a single event upset. The FDS had already shown memory degradation. Engineers had previously devised clever workarounds. The leading theory, a new, more complex corruption, perhaps a cosmic ray strike creating a feedback loop. Another possibility, a sudden power fluctuation from the aging radioisotope generator, causing a cascade of errors. Engineers modeled power failure scenarios. None matched the 1024-bit signal. The final conventional explanation, a dormant software bug, triggered by a unique combination of low power, memory decay, and command sequence. Proving this was difficult. With Voyager silent, only Earth-based simulations could be run. Each hypothesis was tested and ruled out one by one. The anomaly resisted easy answers. The team pressed on, determined to find the truth. The mystery endured. After months of investigation, JPL reached a conclusion, both technical and profound. The culprit, a cascade failure originating in the Golden Record's control hardware, dormant for decades. A powerful cosmic ray struck the record's interface circuitry, causing an electrical surge that bled into the FDS. The FDS, struggling with corrupted memory and low power, misinterpreted the surge as a command. It began reading a fragment of the Golden Record's own operating system, twisted and repeated by the dying computer. The prime numbers and geometric patterns were echoes of elegant 1970s code, not alien messages. The tiny Doppler shift was explained by a small gas release from a thruster valve, also triggered by the surge. Voyager's final act, sending us an echo of our own message, a beautiful, accidental piece of cosmic poetry. The mission ended not with failure but with a meaningful event tying its beginning to its end. Voyager 1's final transmission is a powerful reminder of why we explore. These missions extend our senses, leaving a legacy that outlives their creators. The Voyagers will drift for billions of years, carrying our story. This event highlights the challenges and rewards of deep space exploration and the resilience of human ingenuity. The solution was complex but deeply human, a final chapter written by physics and our own creation. The lesson: future missions need even more robust self-healing systems and advanced AI. Voyager's finale gives us invaluable data for the next generation of explorers. Its last whisper was not a cry for help, but a reflection of ourselves, and a call to venture further into the cosmic ocean.